Hello, my name is Beasley, and I'm a part of Challenge 2016. This is my seminar video. So, for the seminar video, we're giving a choice of two problems, and I chose problem number 50. And the problem is an initial value problem. So that basically means that we're going to have to find what the C is after we integrate a function. Now, as we know, whenever we integrate an indefinite function, we're going to get a C as a remainder. So say if we were integrating x, and we have to integrate it indefinitely, which means there are no boundaries, we would get x squared, because you raise the power by 1 and then divide. So x squared divided by 2. And then we have the constant c tacked onto the end plus c. Now, normally we would not be able to find the value of c. However, if we are given an equation and an answer to the equation, we can find c. So if we are told that, so for example, we are told that, say, y of 1 equals 0, then we'd have to figure out a way for the equation after integrated to equal 0. So if we have y of 1 right here, we have to figure out how this would equal 0, or what c value would make it equal 0. So you go ahead and plug in 1. So x equals 1. 1 squared is 1. And then now I mean the c must equal negative 1/2. Because 1 minus 1/2, 1/2 minus 1/2 is going to be equal to 0. So we're given the same situation essentially, except with a different problem. So we're given the problem, the square root of x squared minus 9 dy over dx is equal to 1. Now, first step here is we're going to do algebra and isolate the dy over dx. We need that out of the way. So we have the dy over dx is going to be equal to 1 divided by the square root of x squared minus 9. So once we have this, we're at a place where we can begin to integrate the function, or it's a form where we can integrate the function. So we go ahead and integrate this. That's going to disappear and just go to y. We integrate this, and we're going to get the natural log. I'll write it right here. The natural log of the absolute value of the square root of x squared minus 9 is equal to y. Now, just to sort of backtrack for a second, so you understand how I got this. The natural log of the integration of 1 over anything, which I'll notate as x, is equal to the natural log of the bottom of the function, the denominator, or the x. So we're just going to do the same process here. The natural log of 1 divided by the square root of x squared minus 9 is basically going to be equal to the natural log of the square root of x minus 9. So that's how I got to that. Now, at the beginning of this problem, we're also given the initial conditions that y to the 5th is going to be equal to the natural log of 3 whenever x is greater than 3. So, and we can actually, instead of having y right here, we can just go ahead and make it y of x. So, we're basically going to say what value, big mistake, I almost forgot here. Or not a mistake on my part, but just a mistake that you would want to keep up with in general. You're gonna want to write a plus c, as I showed earlier. Because whenever you integrate indefinitely, you can have a plus c right there. So we're gonna try to find the value of this c by plugging it in right now. So we have the y of x, which is y to the 5th, we know. So y to the 5th of the natural log of the absolute value of the square root of x squared minus 9 is going to be plus c, is going to be equal to the natural log of 3. Now let's go ahead and simplify the inside right here. And I'm going to erase a lot of this so that we can have room to simplify. So the natural log, let's go ahead and take a step back. The square root of x squared, we're going to go ahead and plug in 5 for x. It's going to basically be 5 squared minus 9. 5 squared is 25, and then 25 subtracted by 9 is 16. So we're basically looking at the square root of 16, which is going to give us 4. So now that we've simplified it, we can go ahead and write the natural log of 4 plus some unknown value, or some unknown constant, c, is equal to the natural log of 3. Now, if we go ahead and go back to the properties of natural log, we're going to remember that the natural log of x times y, or a number times a number, is equal to the natural log of the first number plus the natural log of the second number. And this is going to come in handy here, because we have the natural log of 4 plus some number equals the natural log of 3. Now we go ahead and we look at this formula and we say, what number which abides by this formula can give us the answer, the natural log of 3. So if we make c equal to the natural log of 3 over 4, or 3 divided by 4, this might work out so that we can get the natural log of c as the answer. So we have the natural log of 4 plus the natural log of 3 over 4. And this plus means that we're actually going to be multiplying the two numbers, is equal to the natural log of the two inner numbers multiplied by each other. And 3 over 4 multiplied by 4 is equal to 3. And that's actually the answer we were looking for. So to make this all more clear, we can now determine through all of this that c is equal to the natural log of 3 over 4. And that satisfies the equation so that the natural log of 3 can be found from the equation that we had earlier. Thank you. My name is Beasley again, and this is your video.